This last class, we were looking at a few things about what the general, we saw some entomology. Essentially, we were studying the words which we are using here. So, for example, philosophy is love of wisdom. Philosophia. So, we are loving wisdom. And I don't know if you'll agree, wisdom is supreme. Wisdom is what we are all looking at, and we want to gain wisdom. Then we saw that there's something called scientia, science or knowledge. So, science has been derived by observing facts. Why did the apple fall on my head? So many other things were observed. And it's really nice to think that people were very interested to find why light is behaving in a particular manner. They didn't take it for granted. And so many other things have been observed, they have been given an explanation, and that's why science has evolved. We've done a lot of science everywhere. Now, when we look at it, these two are what we call as the thinking part. The other side is the place where we start to do things. What are the things we are doing? We are going to do something intelligently. We are going to do something intelligently. And we are going to create solutions. We cannot create solutions without having facts in place. So, this is what science does for us. Science helps us when we are creating a solution. And of course, there's again the technology. So, again, it's like an art and craft. There are specific tools, and we are trying to use a skill to execute something with these tools. Now, if we are looking at this waterfall like movement of data, essentially here you got philosophy where you're trying to look at some logic. Then we go for science, which explains it. We are trying to get some application. This is engineering, and we use tools. Now, we saw this example. Biologists told us that there are anaerobic and aerobic processes. So, we identified that biologically, suppose anaerobically we are trying to do a particular work, it's going to be better. So we started to apply these principles for the solution of our sanitation problems. Okay. Now, one of the things I'll probably add is when I look around, when many of the people are doing their construction work, they know they need a septic tank, but they don't know that a septic tank has certain elements. For example, what are the elements of a septic tank? How many chambers are there? Very good, there are 3 chambers, and there is something called contact time. That means the material has to be in a particular chamber for a particular duration so that the end liquor which comes out is not harmful for human beings. If it is not having the sufficient contact period, then there is a problem. There's a certain velocity in which only the material should flow through. Are we giving that much time? Because today, if you go around, especially in Vellore, you'll find that all the houses are constructed almost wall to wall. There's no compound wall also. One wall of the wall of one house is the wall of the other one. So when this kind of a setup is there, when this kind of a environment is created, you find that it is very difficult for us to establish our scientific requirements, like our engineered requirement that this septic tank requires so much space so that it does its work properly. Okay, so this is probably what engineering is about. Engineering designs the solution. Technology is the tool which allows you to bring that together or assemble it together. Let's take the example of a pipe wrench. It's a tool. Okay, so it essentially is trying to help you to work so that it is more efficient when you work with the pipe. Okay, so you will find that this particular table sums up what we are trying to talk about. Okay. Now, let's move on to some part which I want to share with you. I want you to know that we are going to talk about IFCs in this particular session. IFC is Industry Foundation class. Industry Foundation class is not very new. Point on, we are trying to go for the lecture of today. So, now we talked about a tool of screwdriver last time, remember? So, if you look at the screwdriver, there is what is called as the Phillips screwdriver head. Okay, we got the flat, we got, there are so many other types, square, hexagonal, and you'll find that if somebody wants a screwdriver, you need to know what kind of screwdriver you need. These are a few of the definitions. Now, let's go ahead. We want a tool. Tool is the topmost in the hierarchy. After tool, we are specifically talking about screwdriver. Within screwdriver, we understand that there are lots of different kinds of screwdriver. Okay. Now, we need to know quite specifically what we want. See, for example, now we have more things. There can be the shaft length, diameter of the handle. You would have noticed that a large diameter handle helps you to operate the screw more easily, right? So, what kind of tip is there in the screwdriver? And also, what is the total weight of the screwdriver? Sometimes that is something which you can also talk about. Performance rating, how much torque can you apply on the screwdriver? For example, when we had the cassette players, we had what was called as the head alignment screwdriver. It's also a plus type screwdriver, but it's a very, very, very narrow needle-like shaft. So, do you think I can go and use that to open, let's say, the screw on the switchboard? Quite frankly, no. So, we need to know the torque rating. Again, for some cases, magnetic tip is helpful. Other cases, magnetic tip is a no-no. For example, if I'm going to try to open a cassette where there's a magnet, so again, a very old technology I'm talking about. I don't know if you guys saw the cassette tape. I am at least glad you know what I'm talking about. So, when you are looking at the magnetic tip, it is going to affect the cassette. And again, if you look at a hard disk, the hard disk has where there is a spinning magnetic disk. Today, again, the technology has changed. You cannot take a magnetic device near it. Ideally, it's better to avoid magnetic substances near it. So, we need to know a lot of other things. Again, how hard it is, the tip. Sometimes you need a hard tip, sometimes you cannot have a hard tip. So, basically, there is another thing, there is the screw also with which we are talking about. So, if there is no screw, what is the point in having the screwdriver? So, again, what are the parameters you need to know about the screw, the pitch, what type of head is there, so on and so forth, what material is being used, and a lot of other attributes. So, what I want you to understand is, whenever you are having an object, you start to describe the object. So, how will somebody describe me? He is a man, he is having a height of so many centimeters, build is like this, looks Asian, doesn't have a mustache or didn't have a mustache on the day I saw. On the day I saw, he was wearing a glass specs. So, these are some of the things which you try to tell to describe the person. Suppose you are going to describe to a artist, that person is going to probably draw. That's what they do for identifying criminals, right? Or nowadays they all do it with digital thing. You want a mustache, put this, put that. I think I saw this in one of Rowan Atkin's movies. He will describe the assailant, Johnny English. I don't know how many of you have watched that movie. Yeah. So you keep describing, you get an output, right? So here again, when you are talking about an engineering problem, you need to know how to describe the problem which you have. Okay. So again, this is another thing. You can just talk about hand tools. You got hand tools, you got power tools. You can keep going ahead with the classification. It can be a hammer. It can be a very special kind of screw. For example, the screw on the steering column of a car is designed so that the head will break after the required strength is got. Why? So that a robber cannot go and open the screw. It is broken. That's it. So, once the steering column is fixed, it is fixed. So, you need to understand what kind of equipment you are working with. You can extend this to any other thing which we have. For example, look around this room. What are the things which we have inside this room? Can you just list it out? Again, I want you to write it in your notebook. I don't want you to tell me off the top of your head. How many of you have got curtains? Great. Windows, ventilators, then the furniture, there is bench and chair which you're sitting on. Okay. Then there are the CCTV camera spying on you. Yeah, great. What? In this room, not in our room. I only want you to look around. Projector, biometric attendance device. Biometric attendance device, very good. See, this is now a very big thing because we got electrical, electronic, and data-based stuff. Okay, so on and so forth. And then light. Okay, what is the how many lights are there? What is the nature of the light? Rectangle, circular. Okay. 6 circular, very good. 3, 4, 5, 6, 7, 8 circular are there. Okay. 6 are turned off, 2 are turned on. Okay. Then what is the medium which is illuminating or causing the illumination? LED, great. Okay. So now I don't know how many of you are told there are 6 or 9 Crompton Greaves fans. Okay. Yeah. So 9 fans, right? So if you go to SJT, you have BLDC fans, brushless DC motor fans. So what is the advantage of brushless DC motor fans? They are more energy efficient, right? So in fact, I have changed the fans in my house in the bedroom from the normal copper mount to the BLDC. Investment is a little high and I'm in a rented house, so that's why I chose only 2 rooms. But you will find that it's a big saver on the electricity. Okay, so right, so now basically you have got quite a lot of stuff. So now, as I told you, you have got light. You can tell. So let's probably use just the light as our example. In fact, because I'm using light as my example because in my slideshow also I put light. I was hoping people will at least put light, if not the other stuff. Right. So can you see here? Many of you told square. Now you can have L, W, H. Why do you need a H? We need to know how much recess space is required so that the false floor, false ceiling can be adjusted. If you don't know this, then we don't know whether your light can fit in. Right? Now, mount type, is it recessed or is it what you call as mounted on the surface? These are recessed. That means you don't see anything coming out. Like if you have a tube light, it's mounted on the surface of the wall. But here, the whole thing is recessed. You don't see what is happening in the background. Okay. Now, if I'm going to need one more light, what will I do? I'll have to make an opening suitable for the type of fixture I am looking at. Right. So, I need to make an opening in this POP, plaster of Paris, false ceiling, and then I will be mounting the new light. So, if I know that there is plaster of Paris, I will bring a suitable tool to make the opening here. Okay, I will bring a suitable tool to make the opening over here. Right. So, these are some of the things which you need to understand. How many of you have watched Ocean's? I watch very few movies. Okay, so yeah, Ocean's 13. Only one. Only one. Okay. So probably there is a history behind it. That was the movie I watched with my wife before our marriage. Now that is another story. We'll come to that later. Okay. So that's a movie I won't forget very easily. So you'll find that they wanted to find the thickness of the concrete floor so that they can do their work, whatever work they are wanting to do. Okay. Yeah, that is beyond the scope of discussion. Now that you go and find out by yourself, right? Now, another very important thing is we spoke about physical data. We also have the electrical data. What voltage do these light fixtures work? You'll find that now most of the LED fixtures work at 110 or 220 volt. Even much lower voltages, they can still work without any problem. Then, what is the wattage? What is the wattage of the lamp? Because if you know the wattage, you can probably calculate the trip switch which is going to be present, the wire which you have to use, so on and so forth. All of these things go with that. Then we have the lumens, how bright it is, because you have to have a certain lux level at the working level. So light, as you know, it's very intense at the source, and then it keeps on reducing in intensity. So what intensity should be present so that at the working surface sufficient brightness is there. This is another thing which we are concerned about, and we are going to probably work on that. Okay, so on and so forth. Color temperature, whether it's yellow light or white light or something in between, all of that we need to know. So this is color temperature, not the color of the light. It translates to color of the light also, yes. And also we can have some dimming protocols, because many of these lamps don't dim at all the normal way. You can't dim it in the normal way. So you need to have some kind of a protocol for dimming it. So these are all some of the things which we look at. Again, we have some other things, right? You got your projector. So part of my pane area, my projector is, my unit is HDMI. Now I have to get it to VGA standard. So we need to kind of figure out a lot of things when we are looking at just this room, right? How much information is required in this, to use this room effectively. So this is one very important thing which I want you to look at. Of course, if you look at some of the projectors, there's a lot of noise, which is not acceptable, because that's the fan which is inside, which has to be run to cool the lamp. Okay, and one more thing, these lamps have fixed life. So you need to know what is the life of this lamp. Why? Then only we can replace it and we will not have problems when it is in operations. So now observe the shift in the terminology. We were talking about construction, then we have moved to maintenance. For example, this light. What is the kind of light? LED. If I know, I'll come prepared to replace that light with a suitable fixture. I know now the size. So I'll choose the light which I have to replace something carefully. If I have to do some maintenance like cleaning of the entire thing, I need to know what is the cycle or frequency for cleaning. Then only the operation is going to be successful. So can you see that for a person who's going to use the building you are working on, all this information is very, very important. For example, lift. Lift needs maintenance. If it is not maintained, it's not going to be safe, right? So you need to communicate a lot of information to the end user also, right? So these are some of the things which you look at. So for example, you got the different furniture, fasteners, like for example, how many screws, nuts, bolts are here? 1000 plus? Could be, right? So right from the wall on the window, you see there are some fasteners. So everywhere you look at it, we are having all of these things. Now, can you see we have reduced this to a number? Initially, we looked at properties, then we looked at numbers. If I know the number and multiply it with the cost of, and then we got items, we can find the cost of item. So cost of item into numbers, can we get the cost of construction or cost of maintenance, etc.? Right. So this is the very, very important thing which you need to remember. When you are going to work with buildings, we are very data intense, we are very data hungry, but we chose not to go in for the collection of the data. We didn't think of storing the data properly. If we are able to do this, we can actually draw meaningful inferences. If this data is in a digital format, I can ask a program to look at different attributes which I wanted to look at and then give me a solution. Earlier, I might have written it in a notebook. I had to open 10 or 20 notebooks. I might have to have referred to 5 or 6 drawings before I could do the work. And then I would again written it in another piece of paper and done the work. 10 days from now, if another light fitting is going bad, again another person might be doing the same work, right? Open the different documents, open the drawings, understand what is there, and then do the work. So this is what our AI and other systems are going to make it easier. So agents are going to come in to do these works. So what are you going to take from this point till this point? We are doing engineering, which is nothing but an interpretation of science. We are trying to use tools to make our life easy. Then we realize the tools have information. If I know what I have to take for a particular purpose, my work is going to be done well. You can do the work, but we are trying to do it well. It needs to be done faster. It needs to be done efficiently. It should not lead to further waste. It should also make it economically viable for whoever is using. So all of these things are coming in. And I want you to be able to think of data which is around you. I want you to be able to collect the data, use the data efficiently. Okay. Now, before we go further, I want all of you to please stand up, stretch, okay, and then sit whenever you are comfortable. If you want to talk, you can talk now. When you're standing, you can talk. After you sit, please don't talk. Okay. Now, we saw a lot of data. We saw a lot of information which is available. So basically, data is nothing but unordered information. Lot of information, lot of things are there. Now we try to order it. We try to put it put it in context. So we need to be very careful. Okay. So let's say somebody asks you to fix the light. So you need to know which room, okay, which fixture, is it a bulb? Ballast is something like, usually in the mercury vapor lamp, tube lights, other things, we have a coil. It's called a ballast. And then, is it the switch which is faulty or the light which is faulty? Another big question, right? Again, do I need a ladder for doing this operation? Or is something else there which I can use? Do I have to carry something? That is the big question. So, typically what happens is, a person comes to the place, sees what is the thing, takes a decision, then goes back. He'll come, forget that another part is required, and then they go back. On the other hand, let's say that we are having a system which knows what was initially constructed, which knows what are the things that are likely to have gone bad because you didn't do the maintenance. And then it tells, okay boss, when you go there, take a step ladder. Take these parts. You need to have this particular kind of screwdriver because this has the particular system. And a person comes and does the work, it is going to be more efficient, right? So we are going to try to achieve this. We are going to create a virtual copy of the actual infrastructure so that when you come to the infrastructure, all of this is done. Another thing is that there is a danger of over acquisition. You take too much of data and then you will find that you are not able to make sense of the data. There are two parts. So actually, this is one of the reasons why I ask you guys to write your own class notes. Now it looks very simple and all these things, right? But when you go back and find, oh, John has given video. At the end of this, term, before CAT 1, you'll find that a lot of information has come. And when you come to FAT, information becomes like information overload. Okay. So please try to, put this into practice. Information, it can really become very, it can become a overkill for many people. Okay. So here again, we come. If you try to say, I'm going to track everything. What is everything? This is the problem with what we call as the mandate, BIM mandate, which people give. So a customer who doesn't know what they want, they'll say, if I go and ask what you want, they'll say, oh, I want everything. But everything has a cost. Everything has a huge cost. So do they understand what they're trying to do or work on? So for example, you can model every screw which is there in the building. But can you imagine how much time it is going to take to create such a detailed model? Every screw which is there is being modeled. You go for something else. LOD 500, as we call it, is as built. So, okay, there's a screw on this whiteboard here and here. This is the distance. Can you imagine what would happen if that is done? It is good, but the problem is your model size becomes exponentially large. I have noticed that when I start modeling in some tools, initially the model is very easy. You start to bring in windows, doors, and other things. Model size jumps from around 30 MB to 300 MB. And what happens to the poor computer? It's struggling to do the work. It is very slow. You'll make a mouse movement, go have a cup of coffee and come, and still the computer will be going in circles. Okay. So, which is the right point? It's a very difficult question to answer. So, please remember, if you are consulting about 3D modeling, 3D modeling should have a lot of data, but how much, at what point you stop? That is very, very important, because when you are going, you go to library, there are so many books. Will you be able to pick exactly the book which you want? Always quite difficult, right? Even what you call as, in your own thing. So if you collect too much data, the model becomes heavy, updating becomes very difficult, data sometimes becomes obsolete. So initially they had the tube lights here. So tube lights would have had ballast, it would have had the starter, choke, other things, and then it gave similar light, but it's not the same. Now that whole thing has gone. You look at the original drawing of this building, it would still show probably those kind of light fixtures. Unless it gets updated, it's obsolete. Data becomes obsolete. So sometimes 2 or 3 iterations of change would have happened. We still wouldn't have got updated. Okay. And finally, what happens is we lose trust in the system. We say system is bad, but is the system actually bad? No, the way we worked was wrong. So now we need to understand where the sweet point lies. I am not going to tell you where the sweet point lies, because quite frankly, I don't have enough experience in BIM to make a assertion. However, one thing I know, I need to have the whole thing modeled to the requirement. I shouldn't over model, I shouldn't take too many things. Okay. So we need to be using some good practices. Now here comes the important thing. We are going to talk about IFCs. IFCs help us to manage this data sensibly. Okay. Now IFC is standardized in IS 16739. Again, I think there has been a revision. I'm not too sure about what is the latest version, but for now 2018 is one which I have got access to. So I'm just putting this 2018 over here. So here what happens is, the first thing we do is we start to change the terminology to a common terminology. So for example, you look at this one. What is over this window on the outside? Sunshade. But lintel, on the lintel we got the sunshade. Sunshade is projecting out. If you look at CPWD manuals, which are quite old, they call it chaja. Okay. Then there's something called kura. What is kura? KHURRA. Don't worry if it's right or wrong. There's no right or wrong answer in this session. Kura is the downcomer, there's a sort of arrangement, jali, other things. Okay. So if you look at it, we are not able to understand the terms which are here, right? So you go to Kerala, they'll have a different name for tiles probably. Oh yeah, water closet, commode, toilet, are they the same or different? Okay, so this is an example. Tap, faucet. Yeah, so certain terminologies are used probably in some geographies, but then there is a gap between us. So we don't understand fully what is happening. So we need to try to understand this IFCs, because it tries to establish relationships. IFCs are evolving standards. That means as the need comes, they keep evolving. So for example, here are some of the things. It's a hierarchical storage of data. So from the large to the smaller element, we will be having a way of moving data, right? Again, another thing is, for example, there are certain objects. For example, IFC flow terminal, it means it's the air vent. IFC furniture, chair. IFC fastener, screw. Okay. So if you are going to look at this room, it becomes IFC space, right? So it has area, volume, and also it is having some temperature requirements. Gopika had made a post on LinkedIn, right, about the transmissibility of the heat on walls, right? So things like this are going to be coming in. For example, projector, IFC audio visual appliance. This is one example of what IFC does. Okay, and IFCs are used within the architect's software. Okay, so many of the 3D applications you'll find will be talking about IFCs. Okay, so if, for example, we will continue this in the next class. So one thing you should remember, we have a lot of data. We are going to meaningfully store this data, meaningfully recover this data and work with this data. Okay, any questions, please?